A crew in the Chinese city of Changsha started assembling a 10-story apartment building one morning and finished it before the end of the next day. 28 hours and 45 minutes, 3 cranes, 1 site. When the clock stopped, that building had walls, windows, wiring, plumbing, ducts, balconies, and floors you could put furniture on. The time-lapse went everywhere, and it left a lot of people asking the same thing. How exactly does China build a building in 28 hours, and what is being quietly left out of that number? Because it did not stop there. In January 2024, in Shanghai County in Hunan Province, the same company stacked a 26-story residential tower in 5 days, 14,000 square meters, 208 furnished apartments, 4 lifts, and around 100 people on site. Back in 2015, they went much higher, assembling a 57-story, 204-meter tower in 19 working days at a steady rate of 3 floors per day. None of these are sheds. None of them get quietly taken down once the cameras leave. People live in them right now. The man behind the system had never put up a building in his life. He made air conditioners. What turned him into a builder was the ground moving in Sichuan in May 2008, and roughly 70,000 people dying in buildings that came apart around them. And while he was moving construction into a factory, another Chinese company decided factories were still too slow. In Shanghai in 2014, they pointed a machine the size of a warehouse at a pile of demolition rubble and printed 10 houses in under 24 hours at a materials cost of about $4,800 each. Here is what makes this worth your time. The speed is real and the numbers hold up when you check them. But that clock is measuring one very specific thing, and the moment you understand what it counts and what it does not, you also understand why Western companies have burned north of $3 billion trying to copy this, and mostly ended up in administration. If you want engineering stories where the numbers are checked and the caveats are not hidden behind the hype, hit like and subscribe. It genuinely helps. Now, let us start with the part everybody skips, which is why anyone should care how fast a building goes up. Construction is the largest industry on Earth that never really industrialized. Almost everything else you own was made indoors by machines that repeat themselves. Buildings are the exception. Buildings are still assembled outdoors, one at a time, by different trades arriving on different days, in whatever weather turns up. From materials that arrive wet and cure in place. That is not nostalgia. It is a productivity problem, and the bill is coming due. The United Nations Housing Agency puts it like this: by 2030, roughly 3 billion people, around 40% of everyone alive, will need access to adequate housing. Meeting that would mean completing about 96,000 homes every single day. Not starting them, completing them. Today, more than 2.8 billion people already live in housing that fails a basic adequacy test. Now look at who is supposed to build all that. In the United States, the median construction worker is 42 years old. The National Association of Home Builders estimates residential construction needs to hire around 723,000 people a year just to stand still, against a national deficit of roughly 1.5 million homes. A quarter of that workforce is foreign-born, and in the skilled trades, it is closer to 1 in 3. The same story repeats in Germany, in Canada, in Japan, in Britain. The people who know how to build are retiring faster than they are being replaced. So when a Chinese company puts a 26-story tower up in 5 days, the interesting number is not the 5, it is the 100 workers. There is a financial reason too. A building under construction is a hole that money falls into. You pay interest on the land, interest on the loan, insurance, security, crane hire, and overhead. And you earn nothing until someone moves in. Cut a site program from 3 years to 6 months, and you have not just saved labor, you have changed the risk profile of the project, which changes what a lender will fund, which changes what gets built at all. That is the prize. Everything that follows is an argument about how to win it. Zhang Ye founded Broad Group in 1988 with savings of about $3,000. making industrial boilers at a time when a lot of Chinese boilers had an unfortunate habit of exploding. His did not. By 1992, the company had moved to Changsha and pivoted into non-electric absorption chillers, air conditioning driven by gas or waste heat rather than a compressor. That was the business. Buildings were somebody else's problem. Then came the 12th of May, 2008. A magnitude 8 earthquake measured at 7.9 by the U.S. Geological Survey ruptured the Longmenshan Fault in Sichuan. 69,227 dead, nearly 18,000 missing, over 374,000 injured. Around 7,000 school buildings collapsed. What stuck with Zhang was not the magnitude, it was the failure mode. Reinforced concrete is superb in compression, cheap and available everywhere, but under cyclic lateral load, it does not warn you. It cracks, the crack propagates, the section loses capacity, and the floor above arrives on the floor below. Steel behaves differently. Steel yields. It deforms, absorbs energy, and bends before it lets go. And that ductility is the difference between a building you walk out of and a building you get pulled out of. So in 2009, he founded Broad Sustainable Building with a fairly radical brief. Stop pouring buildings, manufacture them. The Lego comparison is closer to literal than most people assume. The building is broken into modules 12.19 meters long, 2.44 meters wide, and 3 meters high. That is not arbitrary. That is a 40-foot high cube shipping container, which means the modules fit existing ships, trailers, port cranes, and customs paperwork anywhere on Earth. Inside the factory, each module is finished completely. Structure, insulation, wiring, plumbing, ductwork, ventilation, windows, internal finishes, kitchen units, water tanks. When it leaves the plant, the only things missing are the appliances you would carry in yourself. Then, the clever bit, one wall folds down on site to become a floor plate, and the balcony and window units fold outward. 2 modules opened against each other give a column-free interior around 12 meters by 4.8, which is a real apartment rather than a corridor with a bed in it. The whole system runs on 2 module types, room modules and circulation modules containing the lift shafts, stairwells, and risers. Every building is a different arrangement of those 2 parts. The structural material is called B-core, 2 sheets of 304 stainless steel with a dense array of thin-walled stainless tubes brazed between them, so the plates act as tension and compression flanges, while the tubes hold them apart and carry the shear. The voids get packed with rock wool. Broad developed it between 2016 and 2018 and released it in 2019. And on site, almost nothing is welded. Modules are bolted. Bolting is faster. It does not need a certified welder standing on a windy steel deck. It does not need weld inspection afterwards, and critically, it can be undone. A bolted building can be taken apart and moved. That is the system. Now let us test it against the record, because that is where the honest engineering lives. The headline project is Mini Sky City in Changsha, finished in early 2015. 57 stories, 204 meters, around 180,000 square meters, 800 apartments and office space for 4,000 people, 19 working days of assembly, 3 floors a day, more than 90% of the building arriving finished. Zhang put the cost at about $700 per square meter, but here is the number that never makes it into the viral clip. The American trade journal Building Design and Construction got the full program from Broad's own vice general manager. The 2,736 modules took 4.5 months to fabricate in a factory employing 1,800 people. The foundations took 5 months. Site preparation and crane setup took another 30 days. So the honest project timeline is somewhere around 11 months, of which 19 days were spent stacking. That is not a gotcha, and it does not make the achievement fake. 11 months for a 57-story tower is still extraordinary against a conventional benchmark of 2 years, but it reframes what you are looking at. 19 days is not the construction time. It is the portion of the construction time that happens on the site, in public, where the neighbors have to live with it. Broad has not abolished the work. It has moved about 90% of it indoors, where it can be done under a roof, in sequence by people doing the same task every day with the same jig. Hold the number that way, and the rest of the record stops sounding like magic. The 10-story block in June 2021 was the demonstration of the current stainless generation. The Jindu Tower in Jiangyin in January 2024 was described by Broad as the 16th generation of the design. 16 generations. This is not a stunt that appeared from nowhere. It is a product line being iterated the way a car platform is iterated. And in December 2025, the system left China properly. In Zaid City, Abu Dhabi, Broad completed a 16-story residential tower called Earth Tower for Eagle Hills, whose chairman also built the Burj Khalifa. 259 container-sized modules, 150 apartments, no concrete in the superstructure at all. The modules were manufactured in 30 days. Installation took 96 hours of hoisting operations, spread across a 12-day period on site. Note the phrasing, because the trade press was careful with it and the press release was not. 96 hours of crane time across 12 days is not 4 days start to finish. Eagle Hills now has towers of 15 to 30 stories planned on the same system, each targeting under 6 months, at costs it describes as comparable to conventional construction. Comparable, not cheaper. Hold on to that word. Now, the other approach. If the problem is that buildings are assembled by hand, why bother with a factory? Why not print them? The company that made this famous is Yingchuang Building Technique, known internationally as Winsun, run by Ma Yihei. In late March 2014, in Shanghai's Qingpu district, Winsun unveiled 10 single-story houses it said had been produced in under 24 hours, at a materials cost of about 30,000 yuan each. The printer is a gantry machine roughly 10 meters wide and 6.6 meters tall, which took about 12 years to develop. Instead of ink, it extrudes a paste of cement, sand, glass fiber, and crushed demolition waste, laid down in beads, layer on layer, following a digital file. But there is a correction to make because it gets repeated constantly and it changes the engineering picture completely. Those houses were not printed standing up on their plots. The walls and components were printed flat in a factory, trucked to site, and assembled there. Winsun's own description confirms it, which means the 24 hours refers to printer time on components. And there is a deeper problem the method has still not solved. Concrete is weak in tension. Every reinforced concrete structure you have been inside works because there is steel embedded in it running in more than one direction. Vertical bars, horizontal bars, and transverse ties wrapping around them. Printing fights this directly. The nozzle lays continuous horizontal beads, and there is no clean way to push steel across those layers while the machine is running. The published research is blunt. Reviews from 2025 describe a fundamental conflict between layer-by-layer fabrication and conventional reinforcement, and they identify the missing transverse steel as the specific problem because that is what governs shear capacity and seismic ductility. One 2025 study in Scientific Reports tested printed columns with glass fiber reinforced polymer cages installed afterwards. They carried roughly half the peak load of identical mold cast columns. They failed more gradually rather than shattering, which is a real safety benefit, but half is half. So printing is genuinely brilliant at some things. Curves cost the same as straight lines because the machine does not care. Formwork disappears, and formwork can be 35 to 60% of the cost of concrete work. Complexity is free. What it is not yet is a way to build tall, which brings us to the trade-offs. And here I want to be careful because there is a version of this video that just repeats the manufacturer's brochure. The claim you will see everywhere is that B-Core panels are 10 times lighter and 100 times stronger than conventional alternatives. That claim is Broad's own. I could not find independent certification behind it, so I am flagging it rather than repeating it. What does exist is a proper independent analysis by Brian Potter, a structural engineer who writes the Construction Physics newsletter, who ran Broad's published panel specifications through standard calculations. On raw bending strength, the panels are impressive. The heaviest 6-inch panel could span close to 60 feet before strength governs. But floor systems are almost never governed by strength. They are governed by deflection, by how much they sag, and deflection depends on geometry and stiffness rather than material strength. Apply the standard American code limit and the span drops to about 34 feet. Then there is vibration. Because these panels are thin, light, and have no concrete topping, a floor built from them will bounce underfoot in a way people notice and complain about. Design that out and the practical span falls to around 16 feet. And when you look at Broad's actual buildings, that is roughly what they do, breaking spans down with interior beams to 12 or 14 feet. Then the cost. Stainless runs 2 to 3 times the price of ordinary structural steel, and B-Core uses stainless for everything, including parts that are only in compression where cheap concrete would do the same job. Potter's conclusion, from raw material costs alone, was that B-Core may be the single most expensive flooring system in existence. And what stainless buys you? Corrosion resistance is a problem galvanizing or paint solves for almost every building on Earth. The commercial record is the sobering part. Broad reportedly spent around $650 million developing its original panelized system. By 2012, 16 buildings had been built with it. By 2016, the Financial Times counted around 30, and reporting from that period indicates the venture had not made money. The 838-meter Sky City Tower, meant to prove the whole thesis, broke ground in 2013 and never went up. Even Mini Sky City was cut from a planned 97 stories to 57 because of an airport. 17 years, 16 generations, record after record, and the technology still has not displaced conventional construction in its home market. China set a target in 2016 of 30% of new buildings using prefabricated methods within about a decade. By 2018, the figure was 13.9%. So if the technology works, why has nobody won with it? The answer is the factory, and the West has now paid an expensive tuition fee to learn it. A conventional builder has almost no fixed costs. Work dries up, you release the subcontractors, you shrink. A modular builder has a factory, and that factory costs roughly the same whether it is running flat out or sitting idle. Modular construction is not a construction business, it is a manufacturing business, and manufacturing businesses die without volume. Katerra tried it in America, founded in 2015 to industrialize building. SoftBank and others put in more than $2 billion. At its peak, it claimed 8,000 employees. It filed for Chapter 11 in June 2021, having never persuaded developers to abandon the subcontractors they had used for 20 years. Britain managed worse because the British failures took public money with them. Ilke Homes was the model everybody pointed at. Homes England backed it. In December 2022, it raised £100 million to scale to 4,000 homes a year. It was actually delivering around 350. In June 2023, its investors looked at the cash burn and stopped. 1,150 people lost their jobs, and the debts came to more than £319 million, roughly 68 million of it owed to the taxpayer. Legal & General shut its modular arm the same year, so did 2 others. In under 2 years, the British modular sector essentially collapsed, and in every post-mortem, the diagnosis is the same, and it is not technical. The factories were fine, the buildings were fine. What killed them was that the planning system delivered orders in unpredictable lumps, and a factory cannot survive on lumpy demand. Now, compare the one economy that made it work. Singapore did not subsidize modular companies. It changed the rules. Since November 2014, selected residential sites released through the government land sales program carry a mandatory requirement to use prefabricated, pre-finished volumetric construction at a minimum of 65% of superstructure floor area. The Building Authority reports productivity gains of up to 40% in manpower and time. Singapore did not need a better module. It needed to guarantee somebody would order modules next year and the year after. The same lesson is showing up in printing. In Georgetown, Texas, the technology company Icon teamed up with Linar and Bjarke Ingels Group to print 100 houses at a development called Wolf Ranch, completed in 2025 and now the largest 3D printed community in the world. The prices started in the mid-400,000s. Read that next to Winsun's $4,800 houses. Both figures are true, and they measure completely different things. Winsun quoted materials for a bare shell. Linar sold a finished, code-compliant, financed, warranted house on land with foundations, roof, mechanical systems, permits, and a mortgage attached. Printing the walls addressed one slice of that stack. To be fair, Linar's chairman says costs and cycle times both roughly halved between the first houses and the last, and a second community of around 200 homes is planned. That is the same curve Broad has been climbing for 16 generations. So, where does this land? China has not discovered a magic building method. It has demonstrated at scale and repeatedly that if you keep a factory loaded for 15 years, you can move the overwhelming majority of a building's construction indoors and cut the disruptive, weather-dependent, publicly visible part of the program down to days. The stainless steel is questionable on cost. The panels are limited by vibration rather than strength. Printing still cannot solve reinforcement. The 28 hours is assembly time, not build time. And none of that changes the core finding, which is that the bottleneck was never the machines. Katerra had the machines and $2 billion. Ilke had the machines and a government behind it. Both failed because nobody guaranteed them a queue. Broad survived because it is attached to a profitable air conditioning business that could absorb 17 years of losses. And because it kept building, when only 30 customers showed up. The world is short around 96,000 homes a day and running out of people who know how to build them. The tools are sitting in a factory in Hunan province, already proven, already exported, already inspected by foreign regulators. What is missing is not engineering. It is somebody willing to place an order big enough and steady enough to keep the line running. That is a policy problem wearing an engineering costume. If this is the kind of breakdown you came here for, drop a like, subscribe, and turn on notifications so you catch the next one. There are more videos on screen right now if you want to keep going. Here is my question for the comments. Singapore fixed this with a procurement rule rather than a technology, and Britain spent hundreds of millions and got nothing. What would it actually take for your country to guarantee a factory 10 years of orders, and should it? Tell me below. I read all of them.